right, let's look at the 7-2 homework where we're solving systems of 3 equations. So there's going to be a couple kind of like this. So this is similar to the one we did in class, if you think about it. What we've got is $145,000 to split amongst 3 investments. I meant to highlight that, not cross it out. All right. And we want to know how much was invested in each. So what we're going to do is pick our variables. I'm going to let S be the money that went into stocks. I'm going to let B be the money that went into bonds. And I'm going to let C be the amount of money that went into CDs. So now notice 3 unknowns, so we should be able to come up with 3 equations. So the first is that we're spending all this money. So S plus B plus C needs to equal 145,000. All right. What else do we have? It says that they invest this much more in bonds than in CDs. So bonds has more money in it than CDs. How much more? 25,000 more. So see, 25,000 more in the bonds than in the CDs. So if you knew that CDs was 1,000, that would mean that bonds are 26,000. Okay. And lastly, it says the income from the investments is 8,375. So what that means is that if you add up all the interest, it should equal that. Well, it looks like the CDs are getting 5.75. Make sure you put these in decimal form. So if I multiply the amount in CDs by that, I'll have its interest. Now 0.029 is what the bonds are paying out, and 0.074 is what the stocks are paying out. So now we have to put these equations together somehow. And substitution looks like it's going to be our deal here. Notice they tell me what B is pretty much. B is C plus 25,000. So I'm just going to plug that in for this C, and I'll be down to just 2 equations with 2 variables in them. So let's plug it into the first one. We'd have S plus B plus, oh, you guys, I just wrote that all completely backwards. Well, not completely backwards. We're plugging this into B, not into C. You see, B equals that. So for our B's, we're going to plug in C plus 25,000. So there's the first equation. So see, I've just plugged this in for the B. And then I'm going to plug it in for the B down here. So let's fix this real quick. This is S plus 2C equals, I can go ahead and move that 25,000 over. So 145,000 minus 25,000 would be 120,000. All right, so here's one of my equations. Now let's plug it into the last one. So 8375 plus 0.0575C plus 0.029B, which is C plus 25,000, plus 0.074S. And now let's just fix this because it's a big mess. Oh, I forgot my equals sign in there, you guys. Equals. All right, so we have 8375 is equal to 0.0575C. Now I'm going to distribute this, 0.29C, and then let's see what 0.029 times 25,000 is going to be 725. We're running out of room. All right, now I can add these 2 together, and then I can also subtract that 725. So 8,375 minus the 725. is going to give me 7,650. And then 0.057 plus 0.029 is going to give me 0.086C plus 0.074S. So now notice I have two equations, two variables. So I'm going to do substitution again, you guys. I don't know why. I'm all about substitution. So I'm just going to delete this stuff here at the beginning, except, oh, I kind of needed one of those. Oops. So let's just rewrite. We know that bonds are equal to 25,000 plus C. So we got to keep that in mind here. So notice that first asterisk, I can solve for S. And now this is what S equals, so just plug it in for that S in the second one. So we have 7,650 is equal to 0.086 C plus 0.074 S, which happens to be 120,000, minus 2C. So we've got 7,650 equals 0.086 C. And now we're just distributing that. So we need 0.074 of 120,000. It is 120,000, right? I hope so. It wasn't supposed to be 12,000, was it? I hope not. Okay. Sometimes I'd put too many zeros in things. So I'm getting 8,880 here. And then 0.074 times that -2 is going to give me 0.148 C's, pretty sure. All right, so we can, oh, yep, see, look, we're going to get, oh, no, this will be, all right. So I'm just going to subtract that 8,880 from both sides. So that's going to give me -1230 equals, and then we have 0.086 minus 0.148, which is -0.062 C's, and we'll divide both sides. So C is going to be equal to, we have that 1230 divided by the 0.062. Oh, it didn't come out even, you guys. I bet it was that 12,000. I'm not backing all the way up. So be very, very careful with your decimals. Let's see. We had plugged in 145,000. Oh, no, minus the 20,000. All right, so that looks good. And then we had the 8375 minus 725. So I'm getting an answer. It's just not a perfect one. So let's see. I'm pretty sure that this one should come out nicely. I think it did last time. Where are we at? So somewhere we've got, I'm guessing it's a decimal. Process is the same, so I'm just going to finish this off. So dividing both sides here. Okay, so we have 1230 divided by 0.062. I'd be getting 19,838. I'm going to go ahead and round that to 39. So this is the C that we would get. Now, what are we going to do with that? Well, you back on up. So we're saying we're putting this much into the CDs. So now I can plug that in here. You see that orange equation up there? So S is equal to 120,000 minus 2 of these. So 19,839. 19,839. So we're going to have 120,000 minus 2 times 19,839. So that's 80,322 is going to be our amount in stocks. And then lastly, our bonds. Now remember, we had that little equation from earlier. We know that whatever we put in CDs, we put 25,000 more into bonds. So 19,839 plus 25,000 is going to give me 44,839. So carefully work through it. Use your calculators, make sure your decimals are getting in there right. So just be really, really careful with it. And then when you do get your answers, remember you can go back and check. Okay, so they should add up to 145,000. They should, in my case, the CDs plus 25,000 should equal the amount in bonds. And then also, if you take all of your percents, they should add up to, in this case, 8,375. So now I think the second one, all right, so this second one is very, very similar, you guys. Oh yeah, it's practically the same question. Okay, so same question, same question. This one's a little bit different, so we'll look at this one. So here at Edmonds College, it says that they offer math courses, English courses, and philosophy courses. And notice, essentially, I'm going to figure out how many of each they're going to do. So how about if I let M be the number of math courses? We'll let E be the number of English courses. And we'll let P be the number of philosophy courses. All right, so then it says the college needs to make available 4 less English sections than math sections. So however many you have for math, subtract 4, and that's going to be the number of English. Okay, so 4 less English sections. So if I had, say, 12 math, 12 minus 4 would be 8, so I'd have 8 English. Okay, so English is always going to be M minus 4. The second part says there's always half as many philosophies as English. So how many philosophies? Well, half of English. So if there's 12 English courses, there's going to be 6 philosophies. So philosophy course, half as many. Available classroom, all 3 have to add up to 59. And so now, by the way, the last one and this one, there's so many different ways you can do this, you guys. I don't know what we can. Here's an equation that only has M and E. So if I were to plug this one in for this P right here, I would have another equation with only M's and E's. And essentially that's what we're trying to do here, is get down to just 2 equations and 2 variables. So if I say, okay, here's my first one, M minus 4 equals E. My second equation is going to be M plus E plus, well, philosophy is half of English. So 0.5 English is going to equal 59. You see? So M plus 1.5 E equals 59. So now I have 2 equations, here they are, in just 2 variables. So we can, well, heck, that first one's already solved for E. So why don't I just plug this in for that E right there? So M plus 1.5 times E, which happens to be M minus 4, is equal to 59. So M plus 1.5 M's minus 1.5 fours is going to be 6, right? That should be 59, which means 2.5 M's. We're just adding the 6 over, so that's what, 65? So now we just need to divide 65 by 2.5, and we have 26 math courses. Well, remember, there's 4 less English, so there must be 22 English. And then remember, philosophy has half of English, so it must be 11. So essentially, we plugged m into this one here. 26 minus 4 gave us 22. Then we plugged that one into here, and we got 22 over 2, which is 11. So we got 26, 22, and 11. And so then you'll just stick those in there, 26, 22, and 11. All right, let's see. 3 variables. Should we do the one that says it's hard? So these last 3 are the same thing, but they're given to you in this kind of form. So they're given, it's not a word problem. They've already given you all of the equations. So we just get to play with them. And remember, essentially the idea is the same. We're trying to whittle it down to just 2 equations with just 2 variables. So it looks like it might be easy to get rid of the y. So what I'm going to do is I'm going to label them over here just so you can see what I'm doing. So notice if I were to add b and c together, this would actually eliminate one of the variables. Here's b. You see, these are already given to you all lined up, so they lend themselves really well to the addition method. So see, if I just add b plus c, I'll get negative 2 plus 1, which is negative 1x. The y's cancel. 1 plus 5 is 6z, and 16 plus 20 is 36. So they go together very nicely. So now what I want to do is I want to pick either a and b or a and c and get rid of that same y variable. So how about a and c would already be opposites? Notice if I did 2 times a and added it to c, my y's are going to cancel. So let's multiply the entire a equation by 2. That would give me 2x plus 2y minus 2z equals negative 2. See, I just multiplied everything in a by the number 2. Now remember, c was x minus 2y plus 5z equals 20. So now when we add these together, see the y's cancel again. So 2 plus 1 is 3, 5 minus 2 is 3, 20 minus 2 is 18. All right, so now we have, look at these equations, 2 equations in just 2 variables. So now we can solve these. We could stick with addition if you want, so we just used it. How about if we multiply this one by 3, the whole equation? That would be negative 3x plus 18z equals, just to be safe, I'm going to use my calculator, 108. Now the reason I multiply by 3 is so that I could get this 3 in front of the x in the other one to go away. So now we'll add these 2 together. X's are gone. 18 plus 3 is 21. So I have 21 z's, and then I have 108 plus 18, which will be 126. And now we're just going to divide that by 21. And I get that z is equal to, that is a 6, you guys. Isn't that pretty? Now just start working your way backwards and finding the other ones. So I'm going to plug that in to one of my 2 highlighted ones there, because those were the ones with just x and z. So I don't even want to just plug it into the first one. So negative x plus 6 times z equals 36. So negative x plus 36 equals 36. So notice when I subtract the 36, I get a 0. So that means that x must be 0. And there's nothing wrong with that. So x is 0. Now that I have x and z, I can go back to the originals and just pick one of those. How about the first one? So the first one says that x plus y minus z should equal negative 1. So notice this is x plus y minus z equals negative 1. So if I just add the 6 to the other side, I get that y is 5. and I have them. And remember, you can always check. So you can go in here to the original and plug them in and see. So let's see, the first one says that x plus y minus c should be -1. So 0 plus 5 minus 6 is -1. Perfect. The second one would say that 10 plus 6 is 16. Yep. And the last one would be -10 plus 30 is 20. So perfect, you guys. 0, 5, 6 is our answer. So there's our 0, 5, 6. So that wasn't too bad. All right, so that was the 7.2 homework.